It's my pleasure to introduce members of the consulting companies that have been doing some of the special projects for CSAP. This may help address some of the questions that came up earlier this morning about funding of these types of programs. As I mentioned, they're meant to be, well, one of the goals is to certainly be of benefit to our CSAP members so that we can do our jobs better, more efficiently, and with a better knowledge as we go into the future. And part of the reason for this presentation is to show you some of the results or preliminary results of these programs. And also, you'll see in the membership survey, there's actually a question there. So please look at these presentations and see how you can see them helping you, and provide us your feedback on the comments. So with that, I'd like to start off. Cindy Ott with SLR is heading up a project on bioaccumulation. This will be related to risk assessment studies, I presume. And I call on Cindy to come up and take over. Thanks, Cindy.
Thanks, Guy. So you would have noticed that the first slide that Guy showed, it said food chain modeling, and this one says bioaccumulation approach. So when I started my project, I had questions about food chain modeling, what had to be brought through a food chain model, and all my questions led back to how do you define bioaccumulation, and what is our approach. So this is kind of how my project evolved. So I'm going to go through kind of the scope of the project and what we have as working definitions, the literature review that we conducted, and give a proposed approach for screening cumulative substances. So one of the issue that I had was the eco benchmarks, the standards that we have. They're not protective of bioaccumulative substances, but they are protected of direct exposure. And also, one of the issues that I had and I struggled with was identifying bioaccumulative substances that needed to be put through the process, put through the food chain models. And it's not consistently outlined in the MOE guidance. So I'm happy to see the standards AP came back to hear the talk. There's one tidbit in here for you, so you can stay awake for that. And there's also some special appearances. You can figure out who they are when they come up. And I heard recently people's attention span is about 8 seconds, which is down from like 10. So I'll try and keep moving along. Okay. So the scope of the project was to develop a framework for evaluating bioaccumulation and biomagnification, so we can select the right substances for CSAP submissions for low to moderate risk sites. So this is primarily for CSAP submissions. I don't think this would address all the issues you come up with for high risk sites, but it does address those for low to moderate risk sites. So we met with the MOE to work on the definitions and the approach. And we did a literature review with provincial, federal, and other regulatory jurisdictions to look at their definitions and also their approaches. We wanted to provide some working definitions so that CSAP APs could use those in risk assessments, and also to provide an approach to evaluate the bioaccumulative substances. So where are we at? We met with the MOE. We gave a draft. We met again with the MOE to review the draft, made some changes, and then Scott Steer was our peer reviewer and gave us very good feedback. And we have submitted our final draft to CSAP for review and to the MOE for review. So the goal is so that risk APs can use this in CSAP submissions as guidance for low to moderate risk sites. Okay, so where do we find the definitions for bioaccumulation? The MOE has 4 documents that we looked at that provided some definitions. We looked at the Science Advisory Board. They had a white paper out that they developed a number of years ago, when and what chemicals should be screened. So we looked at that, and the federal agencies, they have definitions in their CEPA, the Act. And the USGS, they have an environmental health toxic substances list. What we found was that the literature and the definitions varied between the MOE documents, and also the definitions varied between the sources. And in our meetings, the MOE, we worked on some definitions, and they're in the process right now of reviewing their definitions, and they are going to update their definitions in the future. So with them, we developed some working definitions in the interim. So these are the working definitions we came up with. Bioconcentration, accumulation of contaminants in an organism from an environmental media, bioaccumulation, so the accumulation from all sources, including food, biomagnification, the increase in contaminant concentration over levels of the food chain, and bioaccumulative. Bioaccumulative is going to be defined as the bioaccumulation and biomagnification processes, but it does not include the bioconcentration processes. So this is a figure sort of showing that, where you have the bioconcentration constant overall trophic levels and the biomagnification as it goes up over different concentrations and different trophic levels. So we're talking about the bioaccumulative processes, and we specifically teased the bioaccumulative and the bioconcentration apart in this, and you'll see how this works through in the approach. And the other thing we did is we looked for bioaccumulative compounds of concern, another acronym, BCOC, to put to your list. So we reviewed several published lists to help establish a BCOC screening list. And the four main lists that we used in compiling our BCOC list are the tissue residue guidelines from BCMOE, the dredge materials management from Mr. Hoffman, and the Texas Commission, which is quite recent, in 2014, and then Ed Corral in 2001. He had put together a screening list as well. We found that in the literature review that the criteria for putting a chemical on the list varied with your log KOWs, and also we found that several substances, they were consistently identified on all the list, so that showed us there was those substances had a significant bioaccumulation concern. So we put together a single list to act as a starting point. And that's our list and the criteria. I'm not going to read through it all, but you can just, that's kind of the basis where our list came from. All right, so someone says you have to say something 3 times for it to be learned, so you're going to hear these steps over a few times. Our approach, our main steps. They're pretty standard. You identify your contaminated media. Everyone does that. Even standards AP do that. Actually, they start doing it. We identify the BCOCs using 2 different options. The first option would be comparing the chemistry data to the list, table 1. The other option would be doing your own comparison of the chemical characteristics of your compound to the bioaccumulative definition. The third would be identifying your receptors of concern and then completing a site model. And then, for step 5, if they're on the site and you've got pathways and receptors, you do a bioaccumulative chemical assessment. So that's the approach that we've come up with. So I'll just go through a little bit more detail. Oops. Yeah. Guiding principles. So we have a couple of guiding principles to help us along the way. And one would be if you have a bioaccumulative substance, but it's less than the numeric standard, then we do not have to carry it forward in the bioaccumulative assessment process. Because it's already been determined the site's not contaminated, therefore, this is one of the guiding principles. The other is the majority of the BCOC substances on the list were developed for sediments, but we're saying that regardless of what your media is, if it's the substance on the list, it has to be considered for all the media, unless you can find some evidence that supports the contrary. We use the maximum concentrations for identifying BCOCs, but you always have the option. You got the option later on to use the statistics to narrow it down. However, if you have a substance that meets numeric standard and you still want to do a cumulative assessment and food chain modeling, you can do that, and the ministry will give you credit, and it will be listed on your instrument. Because there may be instances where professionally that you feel that you really need to do the assessment of that chemical based on the site history or the extent of the contamination. Okay, so this is step one, identifying the contaminated media. That helps us in determining the processes and the definitions that you make throughout the process. So if it's in the soil or the water or the sediment, where it is important. And that sort of is a flow chart. I've got a flow chart that's in the document that helps you step through it all. So standards APs do this and risk APs do this, where you look at whether it exceeds CSR standards. If it doesn't, there's no further action. And then you look at if it exceeds background. If it doesn't, then there's no further action. But if it does, then you have to carry it forward. And then you either do remediation or a risk assessment, and you do a COP screening for both the direct contact assessment and the bioaccumulation assessment. So we're carrying forward with the conduct bioaccumulation process. So identifying the BCOCs, we consult the established list, which is the table 1. So if it's on table 1, then you have to do further assessment for that medium, regardless of the medium. If it's not indicated in table 1, no further assessment is required. So you just go back to doing the direct contact. There's always exception to rules, and so this is our exception, and this is why the standards AP have to pay attention. For protocol 13, which is the screening level risk assessment, we're going to use the procedure 8 definition for that. So you don't have to, you don't consider the list, you consider the procedure 8 definition for your bioaccumulative substances for a screening level risk assessment. Okay, so option 1, looking at the list. If you have a substance on the list, you can eliminate it at that stage on a case-by-case basis if you provide scientific rationale. And one of the instances is if the study that supported the substance on the list isn't supported in your site characteristics or your site, then you can give some rationale why you wouldn't have to do the food chain modeling for that one. Okay, so the option 2, and this is the way that we kind of do it right now. Option 1 was to kind of streamline it, but option 2 is always open if you want to use this option for whatever reason. Then you would use the log KOWs, the concentration factors and bioaccumulation factors to identify your substances. But we're going to define it using the Texas Commission environmental quality criteria in the January 2014 document. And that reference, based on our discussions, is the one that's supported by BCMOE right now. And if you're going to use option 2, then you should provide a table with all your arguments and rationale. So this is table 1, the list of BCOCs for just the metals, just to give you an example of how the list looks, and the variation between the lists of what they identify as BCOCs. Okay, so this is the flowchart representing the what we just went through. So if you aren't, and it's option 1, so if you're not on table 1, then you dismiss it. If you are on option 1, you carry it forward. Okay, then You identify the receptors of concern, and you want to keep in mind your food web. And then step 4, you develop your conceptual site model. So this conceptual site model is critical in supporting and including your BCOCs, and you want to consider the spatial extent, the types of receptors, the routes of exposure, the chemistry. Is it in the sediment? Is it in the water? Are your receptors there? And what does the chemistry say? You look at the types of receptors and the differences in the trophic levels. There we go. You can also look at the physiochemical characteristics to see if it's bioavailable. Okay, so that's sort of the flow chart that represents what you just went through. You identify the receptors, you develop a conceptual model, you look at the significant exposure pathways between receptors and BCOCs. If it's yes, you go do the bioaccumulation assessment. If no, you don't have to do further bioaccumulation assessment, but you have to include a discussion and a rationale in your risk assessment documenting why it's dropped out. And I'd also suggest you write something in the uncertainty section as well. Provide some high points of the uncertainty of that decision. So step 5, here's the food chain modeling, where I started from. You do your bioaccumulative assessment with the various tools that we have. Depending on your site and the area and the receptors, you have a bunch of tools to use. And that's the flow chart that follows it through. And so I want to thank Glenn and Lizzie and Remy, I forgot to put your name, wherever you are, on the list. They were instrumental in helping us, and Michelle Anderson at SLR, and Scott for peer reviewing, and also CSAP for funding. Forgot to put them on too. Thank you. Any questions? How do they do for time? Okay.
I think there's probably time for just 1 or 2 quick questions if we want to stay on schedule.
Okay, sure. Yeah.
First, non-risk assessments.
Yeah.
Can you give us an example that I saw on the Texas list arsenic was excluded, so let's say an arsenic is
Arsenic. Why'd you pick arsenic? So you would look at the arsenic, why they excluded it in Texas and why it's included in the other lists, and then you look at your own site. Is your site
included, so don't you bypass that?
No, if it's on if there's any X's on your on the chemical, you have to include it. But if you're using the option 2, which would be the Texas definitions, then you would probably be able to exclude it, yes. Depending on your site, depending on what they base it on, yeah.
Cindy, could you, maybe you touched on it there, is the relative size of the spatial extent of the contamination relative to the whole range of the organisms that you were putting in the conceptual model a factor that you would expect to be discussed as a rationale for doing bioaccumulation assessment or not doing bioaccumulation assessment?
That could be part of your rationale, yes.
Because I think, although I can, I'm a sediment toxicologist, I've done bioaccumulation assessments, I'm having trouble understanding how to use this guidance to support risk management decisions for what are typically small sites in urbanized harbors where contamination is widespread, and the tools that you're suggesting are going to be picking up this dose from a much wider area than the area that I could actually do any sort of remediation on.
Yeah.
It feels like there's a disconnect here between, unless spatial extent is a key factor that's going to be considered, I don't know how to use this in terms of day-to-day risk assessment.
I think spatial extent is important. And I think the rationale, using the rationale for what your site footprint is and the contamination on your site in the receptors range would be some of the discussions that you want to do to either rule it in or rule it out doing the bioaccumulative assessment. You have to take everything in context, right? Yeah.
So is it fair to say that your report will come out in draft in all of us will have an opportunity to provide CSAP some comments on this before it's
You
final?
tell me you're the, oh no, you're not anymore.
No, I'm not.
I can't answer that question. I think it's gonna, it is in draft right now. And if anyone wants, I guess, input, they can then do it. You'd have to ask the technical, it's at the technical review committee, so I would probably direct your questions to them.
Right.
Okay, thank you.
No more questions, Alex. You can, I see on the agenda just before lunch, we have an opportunity for some questions, and maybe bring it up then. But to keep things moving along, next we have, is it Patrick Lard here to, we have Beth here on behalf of Azimuth to present a discussion on the risk management decision framework. Thanks, Beth.
So I got a text this morning from Patrick. He's sick. So I have a presentation that just have to see how it goes. I do know about the project, but okay, so it's a little bit of a popularity contest. I'm worried because there's a piece of paper that you're supposed to vote for the projects you think need further funding. So just kind of saying there's not many risk assessors out there. The reason this is important to the site assessors is we get all the sites. Oh, should I be nasty or should I be nice? Yeah, thank you, Ava. Okay, so we get all the sites that the site assessors can't handle, right? We get all the ugly, gray, gross, I don't know that I'm doing Patrick a favor at all. Okay, so we get the sites that are in the gray zone. They're usually solidly in the gray zone. And so this work is to help CSAP practitioners take them closer to the white and closer to the black. CSAP, when they are auditing or doing a performance assessment, have difficult decisions about whether they accept the findings of risk assessments. So the purpose of this work is to give us something to lean on. That's why it's important. That was my pitch. I should just stop now. There's going to be a presentation. So you already know numeric risk-based. That's our world. And this project's targeted at risk-based. In the CSR, the acceptability goal for human health is prescribed. There's a number. There's a bright line for us to use. On the eco side, we do have guidance and policy. And I'll go into a few reasons why it's challenging. It's not actually in the CSR, and it shouldn't be. Mike, he always disagrees with me on this point. That's a discussion for later, but I think what we need is a framework, sort of policy guidance that'll help us as opposed to prescribed answers. So we do want these criteria. Professional judgment is all very well, but it's safely deployed in the context of some guidance. So I just want to give you a couple of examples. I haven't actually seen these examples, so work through this with me. Okay, so we're in agricultural land reserve. We've got some cattle grazing. We looked at all the receptors. You need to have healthy soil in the ALR, so we looked at soil invertebrates. We found that they were, no matter where you went, contamination, non-contamination, no effects. So check, acceptable. We did a plant survey, and we had 25% less hay production on this property. And actually, the protection goal for land use for ALR, or agriculture, is 10% and EC 10. You can have a 10% decrease if you go to the guidance. So, okay, we're over. But it's only 900 square meters, which goes to your point. I don't know. Yeah, there we are. So, okay, is that all right? Like, what if it was 50 square meters? What if it was 2,000 square meters? And lastly, we did a food chain model. Say we adopted your new method, and we found that it was fine, except there's a listed species that might use the site. It's not seen on the site. So is this acceptable? And then what if we had this exact same scenario, and it was in a park, like a piece of property on the edge of a park? How would you feel about it? So the context of the decision, the context of the land use does change. There's all kinds of value imbued in what risk assessors do. Another example on the marine side, we're failing our Schedule 9, but it's only 1,000 square meters. Now, some of you would have said, why did she say only? Others would have been, oh yeah, what's 1,000 square meters? Like, it's so variable. If we polled you all and said, how much sediment could be a death trap, and then we plotted the curve, it would have fairly wide boundaries on it. That's why we need to parameterize and understand where the guidance needs to go here. All the toxicity tests had effects, so all three of them, but it was 19 to 25%, and the goal is an EC20. So, okay, how far over is over? How far under is under? So you get the idea that it's really, these are judgment calls that risk assessors are making now. Sometimes it's easy, sometimes it's not. And azimuth does tend to get drawn into the more difficult ones. Some risk assessors say to us, it's really straightforward. So for some parts of the practice, it can be, but not all the time. So we want to have a more formalized process. We'd like to have some guidance, not regulation. And it needs to be defensible. There's all kinds of policy shifts happening in the federal and provincial regulatory regimes right now that affect this kind of work. The changes to the Fisheries Act ripple into this. You know, commercial, aboriginal, recreational fish have different levels of protection than fish, if it was 5 years ago. So this is complex. So we still want to have the flexibility, but we want to bridge off of something. The group who worked on this, Azimuth was just the cheerleader. We just coordinated it. We had a great technical working group. You can see the names up there. We also had David Williams as the sponsor from the Tech Review Committee, and MOEs represented. Our process was we put out a straw dog, they reviewed it, we had a discussion, we made changes. This is sort of a phased process. We're just finishing phase 1 now, and we made a first attempt to develop a framework, how you'd go through a flow chart. This is where I'm hoping I can actually speak to the talk here. So the flow chart shows connections between the risk assessment science that we do and the decision making, the risk management piece. So we decided to kind of, the way our scope of work was originally written, we decided was not the best approach when we had the input from the wider group. So we decided to have 2 outputs from phase 1. One is this flow chart to show people how risk assessment's used. And the other was one spot in that flow chart, we needed more guidance. So those became our 2 deliverables. The second, we're calling it a precursor. It's like the warm-up to finishing. It's phase 1. So the flow chart, going from left to right, it's sort of site assessment world on the left. So in the green boxes, basically PSI, DSI, coming up with a CSM, applying numeric standards, and you're either in or you're out, and off you go into the right-hand side, which is risk assessment world in the 2 gold boxes. The piece that on the far right, we've tried to show the risk management side, and this is really where a lot of guidance and practices come out of MOE recently. How, our different types of certificates, are all the paperwork that we generate, that lives all on the far right-hand side. But it's this spot here, which I think is animated. It's this spot here where we are applying risk-based standards that we felt needed some robust guidance. And so we've put together this flow chart to find a home for what we're talking about here. And now I want to zoom in on that diamond, which is sort of it's a decision point, a pretty important decision point for some sites. Because you remember, ecoreceptors, we've got plants, we've got invertebrates, we've got mammals, we've got bioaccumulative substances, we have different land uses where protection goals might change. So it's like a Rubik's Cube, and there are certain edges to it. I mean, everybody would agree if we had cows who were dead, that wouldn't be good. But what if they get thirsty and drink, 25% more water? So the guiding principles, we started out by saying, well, what are we using now? And we created, that was exciting. we created a table where we compiled all the ingredients that we lean on now. And I'll give you an example of what that looks like. And then we went through and criticized it. So our next step, oh, that's weird. Thought there was going to be, oh. Okay. So, okay, that's fine. So what we have is a table. It has, on the far left, it has which regulatory guidance we're relying on, and then a link right to the spot. And then on the middle column, it talks about what we extracted. So let me give you an example. Risk assessors help me out. In screening level risk assessment, there's a certain square footage for industrial sites, and if you're under that, you don't need to worry about it. What's the number? 1,000, right. So if it's 1,000 square meters, you kind of don't need to include it in the SLRA. So that's not a piece of guidance that's in SLRA. It's not for detailed risk assessment guidance. So we need to evaluate the question, can we port it over? What would the justification be? What's another example? Well, having the land use categories, EC10, EC20, EC50 for different land uses. Okay, what does that mean when you're doing benthic community analysis versus tox testing? So we basically have gone through and extracted from DIRA, from SLRA, from TG7, from the policy decision summary, from the CIST protocols. We've gone through and basically combed and put everything in one table, and then we've annotated it with the feedback from the review group. How am I doing timing-wise? I'm almost done.
You got about 5 minutes.
Oh, perfect. Okay, so we've gone through and put it all in one spot. So now we have the cheat sheet for risk assessors. And it's kind of a difficult thing because there's all kinds of gaps. Like, okay, you know, are there some rules we can start to lean on? Yes, but we're not allowed to yet. So what we want to do is take these from living in all these different places and put them in one place. And so that's phase 2. What Azimuth's going to do now is we're going to create a straw dog guidance based on the feedback we've had so far so that people can shoot at it. We're going to fine-tune the flowchart based on feedback we get. And I'm not also sure about the review process, so that's something I'd like to clarify. I think that what we're doing in particular, that flowchart that I showed you, it needs to get reviewed by site assessors to see how it works. And another thing we hear from people is that this process I'm outlining is really just for complex and hard sites. And I will agree that it comes up, these questions that we have come up more often for those sorts of sites, but any site should be able to go through the process. It just might be easier for some sites. If it's just human health and there's minor eco issues, it'll be far easier to know what its pathway is, but the flowchart should work for every site. So the next thing we want to do is develop some kind of interpretive tool. We don't know if it's a table or a flowchart or a Venn diagram, like we just don't know what it looks like yet. But the idea is it would give us more certainty in the way that risk assessors draw their risk conclusions. And not only that, it would also get into that touchy subject of acceptable versus unacceptable. We know from our practice that there's certain times when we're more likely to need it than others. So parkland, you know, wildlands, like right now we're doing not necessarily that many certificates in wildland settings, but they do happen. So I think that I'm going to stop because now I'm just kind of ranting. I'm happy to entertain any questions you have. I think I have time.
We can take a couple questions.
Okay. Thanks, Ross. Okay, I'm the one that provided the picture of Ross, and he's the one that started to clap. That was very thoughtful of you. If you'd known, you wouldn't have. No. Any questions? Yeah, Mark.
Sure. A lot of the decisions that you appear to be making are, I guess what I would call more policy than science.
This is not a research project. This is developing policy.
And so to what extent do you have buy-in from the ministry? You know, 20 people kill an ounce, whether it's an industrial site or a parkland.
Yeah.
Or
So we haven't got to that part of we haven't got to the hard part yet, Mark. I completely agree. And it's not just the ministry, it's, there's the public, there's other stakeholders. Like, this is not straightforward, but right now we have nothing beyond what is in that table. So we got to improve. It's not going to be 100%. If we can get to 70%, we'll be doing really well. Okay.
Okay, thanks very much.
Vote for risk assessment, risk management.
I'd now like to introduce Ian Hersworth Golder to present his project on toolkits for risk management. I believe this is mainly a hydrocarbon focus, but we'll see from Ian. Thanks.
Yeah. Well, thank you, Guy. So I'd like to acknowledge the CSAP funding, which we're very grateful for. Also, the team that we have here, we have some expert reviewers, John Wilson and Uli Meyer, UBC, as well as an advisory group. The project is co-funded by Shell as well, and so it's a project, as Guy indicates, that focuses on petroleum hydrocarbons, but there is, I think, lessons learned that can be applied to other types of contaminants as well. So one of the rationales, or main rationale, is that the draft MOE Protocol 5 defines some new requirements for groundwater remediation, including a time frame for remediation to numerical standards for applicable water uses. First, there is a draft guidance on monitored natural attenuation and enhanced attenuation. And the project goal is really to develop an improved understanding of M&A and natural source zone depletion and associated remediation timelines, and to provide practical tools or toolkits for practitioners to assess their sites and to predict rates of natural attenuation for petroleum hydrocarbon sites. So we had quite a comprehensive vision to put this guidance or toolkits together. And we started with case study toolkit, and that was really to see what had been done out in other jurisdictions, the literature, and also to collect data from BC sites. Also to develop a conceptual site model. The second toolkit is called Monitoring and Prediction Toolkit, and that's really, I think, the heart of what we're doing. That's looking at what measurement data and what modeling can we do to better assess natural attenuation and source zone depletion. The third is looking at remediation technologies in the context of petroleum hydrocarbons, and if we are going to look at enhanced attenuation, what can we do? And then finally, sustainability. And I've listed the third and fourth as provisional. We refocused our efforts, really. We found that particularly the second toolkit was a large undertaking, and so we're hopeful we can keep going and do the whole project. So toolkit 1. So I'm going to go through a lot of material today. And so hopefully I'll touch on things, and I really want you to know that our emphasis is a practical toolkit, and there will be lots of flow charts. There will be references to material out in the literature, so ITRC, EPA, other jurisdictions, where there are existing toolkits that are useful, and I think, quite honestly, we're not really using or aware of, and there's a lot out there. And then we've developed some new models and tools as well. But if we look at Toolkit 1, that's the conceptual site model. We have multi-site database studies and some BC case studies. We haven't really obtained the data that we were hoping for BC studies, and the door is still open. So if there are sites that you have that you think would provide long-term monitoring data, we'd love to see them. So we've received a number of site data, and some have been useful, some not, so we're still looking. So I'm just going to go through what are people finding at sites. A lot of this focuses on BTEX or benzene, and there are those typical plume studies and plume lengths. The weighted mean of the 90th percentile is about 130 meters. The median plume length for benzene is about 55 meters, not shown there. If you start looking at stability conditions from these multi-site studies, large database studies, the vast majority, around 92 to 94% are stable, but there are some plumes where the plume is expanding, and so that needs to be considered. The next study is one in California. So they have an interesting process where when you submit, and it's not the same as in BC, but when you submit your site information for closure, you need to provide some information on chemical concentrations that's put in a large database, and from there they mine that database and they start looking at, for instance, the effect of different remediation technologies. Before I get to that, there was 4,000 sites, and they came up with a mean attenuation rate for benzene of 0.18 per year. So if that's an exponential type of relationship that you would plug that number into, and if you started off with a typical benzene concentration in a gasoline plume, that would result in about 40 years to get to a drinking water standard of 5 micrograms per liter. So we can sort of use some of this information to develop inferences as to source depletion timelines. We can also, again, look at the remediation technologies, and we can see that SVE was somewhat useful in increasing the attenuation rate, but air sparging was better, 2 times better if you look at the increase in the source attenuation rate. And interestingly, chemical oxidation doesn't look as good, at least based on this database study. The final one I'm quickly going to go over is just one that was again in the US, a number of sites where they looked at remediation timeframes with respect to benzene concentrations. And again, they were looking at a MCL in the US, which is 5 micrograms per liter. And they had a method for estimating what they call the total remediation time frame, which is listed there or stated there, and they used trend analysis. So what they did is they projected forward or in time to try to look at when they would achieve 5 micrograms per liter. And the range is between about 12 and 52 years. I should say that many of these sites were partially remediated. And in fact, some of the remediation was fairly intensive, some of those methodologies I just listed. So, you know, it's rare that you'd completely risk manage a site. So all of them had some type of product recovery, and some had quite intensive remediation. So even with that, we're still, the median time frame is more than 20 years. Now, I presented just two sites that we looked at that had some reasonable results and some interesting ones. I think the one on the right I'll start with is a large deep diesel release. That one is being risk managed aside from some product recovery through skimming. We have wells at the leading edge of the NAPL, and those over about 2 decades have stayed at a similar concentration above DW, but the plume is only 15 meters long. And so it's one of those sites where you have 1 or 2 wells where you're above a standard, but the impact is very limited. The site on the left there is a gasoline release, a small to moderate sized site. Most of the contamination on site was removed, so that would be typical of a lot of service station remediation, but there was a strip of contamination out in the boulevard and the street that remained, a few wells, and those were above DW for quite some time, but we're just finding that they're dipping below the DW. This is a Golder site, and this is one well that just went below DW, but there was another well that stayed just above, and it's hard to know when you're going to achieve drinking water, and there's some continued management and cost associated with that. But again, the overall impact was really limited with respect to the plume. So that's toolkit 1. Toolkit 2, 3 steps. First, evaluation of the progress of M&A. Basically, we found that there's, I think, a gap with respect to M&A guidance. I think there's a lot of good information, but some of the recent advances aren't brought together, and it's hard to find something where you can easily go and find the methodologies that should be used. Second is use of screening models and measurements, and the third is sort of more advanced multi-process models. So a little bit on what we're doing for M&A. So we're not trying to write the definitive M&A guidance, but we are trying to sort of highlight the key things. So we start with lines of evidence. What are the basics? There's some interesting things on methodologies that sort of look at the average concentration or average mass in a plume that you can use with Surfer or Excel spreadsheets, and you can use that to support some of the typical analyses that you do through Mann-Kendall trend analysis. So we'll highlight that. And then, of course, there are the statistical methods. There's regression, and there's non-parametric methods, Man-Kendall, Man-Whitney, and so forth. And there are some new ideas for monitoring frequency. So regression, I'm sure lots of you are familiar with that, and we have a spreadsheet tool. Actually, we're working with Dr. John Wilson. Many of you probably know he's formerly with the USCPA. So he developed that spreadsheet, so give him the credit. He's wonderful to work with. And you conduct that analysis on key indicator wells, and you can project and look at when could you potentially reach a cleanup standard. This is examples for MTB, but you could use this for benzene or other compounds as well. Monitoring frequency. There is some work being done on large data sets and trying to see variability and look at if we had a monitoring frequency of quarterly, twice yearly, annual, how would that affect the results and the conclusions drawn. And this study by McHugh found less frequent monitoring at sites with high short-term variability and slow source attenuation rates is supported, but you would want to do more frequent monitoring at sites with low short-term variability and faster source attenuation rates. Somewhat counterintuitive, although the faster attenuation rates means things are changing faster, and perhaps you need more frequent monitoring. We're going to try to kind of explain this paradigm, but I think one of the important things is they found generally monitoring more frequently than once a year would show more time-independent variability rather than long-term trends and concentrations. So aside from that initial monitoring that you may do to understand your plume behavior, where you may go quarterly for the first fairly short time period, prolonged, more intensive monitoring really doesn't make sense. And there is a tool called MEROS, and also a document by ESTCP in the US that I think kind of unpacks this really well. And so they have this matrix that looks at the stability condition in the plume. There's E, M, and L. L is where you have stable conditions, most likely stable conditions. E is expanding. And then you look at the time to receptor. So you look at how fast groundwater is moving, and then there's that matrix. And so if we look at sort of the extremes, if you have an expanding plume and you're close to your receptor, you definitely want to sample on a quarterly basis. In contrast, if your receptor is the travel time is more than 5 years, maybe sampling every 2 years is a reasonable approach. So now step 2 is the use of screening models. And first of all, we need to understand the processes for degradation. This is now, we're dealing not with M&A of dissolved plumes. We're now moving to the source, the hydrocarbon source. And we have biodegradation, volatilization in the unsaturated zone. We have bio in the saturated zone and dissolution through flowing groundwater. Some of the available tools. ITRC has a control volume model, all 3 processes. But no one has actually put that in computer code, and we're doing that. It's a method based on measurement data. So if you have data on your electron acceptors, you have down gradient wells, up gradient wells, you can look at the differences to develop an estimate of how fast mass is being removed from that source. So that's a nice method, but you need the right kind of data, right kind of well network. Then there are some tools for specific processes. The 3 that are listed there, gradient method, CO2 efflux, and temperature method, are newer methods. Well, the gradient method's not that new, but those deal with the unsaturated zone bio and volatilization. And then there's a toolkit by a company called GSI in the US. They've done a lot of these toolkits. And the take home is with an estimate of source mass, depletion times can be estimated. So this is the ITRC control volume method, and it schematically shows, you have your dissolution, flowing groundwater, you have your flux in the Avedos zone through bio, and then you have bio in the saturated zone. And again, you can look at that through a mass balance of electron acceptors and biotransformation products. So the methods that I spoke of, those 3 methods for looking at that one process, the bio, just shorten it, it's volatilization and bio, but let's just call it biodegradation. And So there are sort of different levels of development. The gradient method, which is where you look at the O2 profile, you get data on your soil properties. It's a well-developed method. It's a simple method, but it's highly sensitive to soil moisture content, so it has some disadvantages. And then there's a method on CO2 efflux, which I'll get into in subsequent slides, and then temperature is a new method. So let's just talk a little bit about the gradient method. So it calculates the biodegradation rate based on an oxygen flux from the oxygen gradient. So you need some data from soil gas, and you calculate the effective oxygen diffusion coefficient from soil properties. So we've developed a spreadsheet tool, actually John Wilson, and to easily implement this method, does some nice things in terms of variable water table, multi-layered soil, so you can get an overall effective diffusion coefficient. You can look at some baseline O2 respiration. And there's also going to be some really, I think, helpful practical tips on how to obtain TPH data. So I think we got about 7 or 8 appendices already, but we're going to have like different, you can go to different parts in the document and you can say, well, if I want to get some geotechnical or soil physical property parameters, what are the methods that I can use to do that? So that'll be in there. The efflux method is actually, this is work, or the schematics by Natasha Sahota. She was a grad student of Uli Myers at the University of British Columbia. Just recently completed her PhD, and she was instrumental in developing this method with Uli. And the schematic there is just a conceptual model, assumes that all hydrocarbons are degraded. And through aerobic respiration, it produces CO2. And so we assume even the methane is degraded, so it's important. Certainly can't get into all the methods, really interesting methods. There's 2 kind of ways of going about it. One's a dynamic chamber. That's the method developed by UBC. It's an infrared analyzer, so we've done quite a bit of work with that technique, and it's just a short-term, quick measurement of the CO2 flux. And then there's something called a static trap. It's a soda lime trap developed by Colorado State University. And kind of it's really interesting. They're saying, oh, you should go with the dynamic chamber, it's better, and Colorado State says no, static, it's composite, you get 2-week data. So actually we have another research project that we're hopefully going to do to actually get side-by-side data. We're quite excited about that. The one critical thing for both methods is you have to correct for background respiration. So what are we finding from these studies? So what we did is we looked at all the literature, and there's a lot of new stuff that's just come out, actually, even this year. We've compiled all that data from the gradient method, the efflux, and other methods. And if we look at all the data, the mass loss rate. So what we're doing now is we're looking at this specific process, and we're starting to get some quantitative data. Ranges between 0.2 and 40 grams per meter squared per day. Really hard to conceptualize that unit, but and if we exclude the static trap data, it's a much narrower range. So we think there's some issues with the static trap, how it's being performed, and I know the folks there, they're trying to refine their method. So, what does this mean? It's all this data, right? Well, again, we can actually maybe take some literature values and plug that into a model, or actually we're developing a very simple nomograph that we can use. So stay tuned. I'm going to present that tomorrow at the Geoenvirologic presentation.
Ian, just to remind me, you already give Peter some time to present for lunch so that I can wrap it up at a conference.
Yep, you bet. This is the database. So we're trying to distinguish between different soil types and depths and so forth. And the last few slides are in the last step of the toolkit, 2. We looked at 3 different models, and screening level models. We'll have some guidance on how to use each of these models. Publicly available, free models, RemFuel, BioScreen, and LNAST. And then we also compared the results to a numerical model. And basic questions we're trying to ask: how long will it take for source depletion? How far will the groundwater plume migrate? And how will source remediation affect the above? So we had some baseline simulations for a small and large release. And it's hard to kind of put this all together in some simple results, but we looked at one simulation set was LNAST model, small gasoline source, and we looked at the years to benzene less than 5 micrograms per liter. We started with a low volatilization rate, 200 years, and we start to increase that where we think we're kind of getting to a reasonable number based on some of those other studies. It's 46 years. It's a model. It's, of course, lots of uncertainty. And then we looked at REM fuel. And the nice thing you can do with REM fuel is you can say, let's say I remove 30% of the source. Maybe that's like product recovery. Or maybe I did a very aggressive remediation with, multi-phase extraction or soil heating, and I remove 80%, which is probably pretty good. Certainly decreases the timelines, but for the set of simulations we did, we found that we're greater than about 20 years. And I didn't say this, but with the nomograph method, we generally are predicting more than 20 years. So you're going to have a pretty small site for that. So conclusions, multi-site data, most BTEX plumes are stable. Plume lengths are relatively short. The source attenuation rates are only slightly greater for the remediated sites. We probably didn't see as large a difference as we might have thought. We're developing a range of tools for prediction of natural source zone depletion, regression, some of these new tools, also some of the older or existing tools that are out there. And then we have multi-process models for answering those questions. So no doubt, natural source zone depletion is a significant process, but depletion timelines and reduction to DW standards will generally be greater than 20 years. The hydrocarbon remediation may reduce timelines, but there's significant uncertainty in the effort to reach a 20-year goal. So with that, Guy, I've probably gone over time, but if there's questions now or later, I'd be very happy to entertain them. So.
Has anybody got a question?
Hi, Ian. Thanks for the presentation. A lot of details here. I'd looked at natural attenuation probably about 15 years ago and used bioscreen model. But then I gave up only because it seemed too microscopic for me, those numbers. And I went on to more aggressive remediation technologies like the dual phase extraction or multi-phase extraction that you're referring to. These days, the focus is more on high-risk sites and trying to get them back to less high risk or no non-high risk. The other emphasis is offsite migration. So where do you see us being able to use this toolkit? In what situations?
Yeah, that's a good question. I really think we can use it for a lot of different cases. For one, we can look at source zones and timelines. I think you were mentioning bioscreen. Was that the model? Yeah, so I think the other thing we can do is use models to predict how far plumes move and timelines. So bioscreen is one of the models that can predict how long that plume will exist and timelines for depletion. I think it can be used for high risk or lower risk sites. I think one of the things that is important is that some of these sites, have very short plume lengths, the limited areas of impact. And so maybe those models will give us better understanding of the real risk and impact at those sites, as well as some of those measurement maybe techniques as well.
Okay, thanks. Thanks, Ian. I'd like to introduce Peter Reed now with Hamera. He's going to give us an update on his the GIS mapping thing. You can explain it to us, Peter.
Excellent. Okay. So I want to talk about three things, and I want to talk about them quickly because everybody's hungry. CSAP instrument map. We started this last year. We got a lot of it done. But what we did is went out for questions, comments, and this year we refined it to make it easier to use, easier to input data in. MOE borehole logs. This is a project not done by CSAP, but done by MOE, and it's a really good project and lots of great data, so I want to just go over that there. And the last one is something that I'm working on now, and it's more collaboration with the educational institutions, because really this project is finished, and this would, collaboration with educational institutions would be the next project for GIS and what we can do with our data we have. So what we did, this is the old, how many people here have used this tool? Show of hands. Come on, higher. Okay, good. So we're getting good value out of it, excellent. So we're going from one version to another version. What we're looking at doing from an overall perspective, we're looking at your knowledge. You've decided whether drinking water applies in the site. It's been checked, it's been vetted, and we're plotting that all out. So we all have a visual representation of where drinking water applies, where drinking water doesn't apply, and you can get immediate access to the certificates so you can see what happens. So if you're right here in downtown Vancouver, James Smith is here. If I'm working downtown, drinking water probably doesn't apply. Southeast Falls Creek probably doesn't apply. Mount Pleasant, hoping it doesn't apply, but we're getting on about the boundary there then, of where it applies and where it doesn't apply. We've got a lot of sites, a lot of data that we can use, and we can see some trends as to where the geology supports drinking water and where the geology does not support drinking water. What we've done this year is we've cleaned up the classification of the documents as to some specific categories that we want to be able to see. We've made provision to put in a representative borehole log, but we're not going to do that. The MOE's got that ready to go, and it works perfect, so we're leaving that there. And if there's any other weird instrument, we can put up there as well. We've made the user interface easier, and that makes it easier for Anna putting in the information that we won't have any errors, so we don't have a site in Edmonton, which unfortunately happened this year, which is fixed. And it'll be easier to fix any errors. So if anybody checks, I check when I do a submission, I check 2 months later and see if it's up there and everything's right. And if there's something that's not with it, I send it back and we fix it to make sure we all have good data to go by. We're also going to, it's all based on, Paul Webb might understand what I'm saying, all based on Java and this and that and something else, but it makes it all easier to go with, and it also makes it easier for us when we're out in the field talking to our clients, we can now haul it up on an iPad. So when this new one comes out, you'll be able to see immediately when you're talking to a client on a new site, how am I going to go about this? You can be able to tell you are so far away from this site, and drinking water didn't apply here, didn't apply here, did apply here. In all likelihood, it's probably not going to apply, or it probably will apply. So it gives you some mobile information that you can use out in the field to be able, or out at client meetings, to be able to say, this is the good work that we've done as CSAPs, and this is what they've all told me. The only question that we've got, and Annette and I have talked about this many times, sometimes it's easier just to apply drinking water because it's very limited remediation to be done than it is to rule it out. So we have these drinking water applies in amongst where drinking water doesn't, just because it's easier to do it that way. You can also filter by certificates or approvals. In principle, you can see how many approvals have been done, how many certificates, where they've been done, where we have where we've had director's determinations. So instead of it's the CSAP that determined that drinking water didn't apply, director determination said it didn't apply. Russell at the MOE did a great database. We talked ahead of time. He went off and did an excellent job. So what he did was looked at all the reports that he could do in the time frame that he had, concentrating on Vancouver, and all the database of what borehole logs were there, and what the hydraulic conductivity of the units were. And that way you'll be able to get information as to whether it can produce water for drinking water to apply, is there a natural confining layer there, most likely, and this step hasn't come yet, but you can also overlay it on top of aquifer maps. So you'll be able to bring it all together into one spot. So this is the one borehole that we're asking for in your submissions. And so where Russell went in and picked a representative borehole and went through the reports and got the information for it, we're asking for it to come through. So I've got this fooled up. So this is a representative borehole, that one of them that he's taken. And what he'll do is he'll say there's a slug test done for this area, and this is the hydraulic conductivity for that unit. And it'll be on the map, and it's mapped from an overall perspective as to where the boreholes are. And this is all, where the CSAP stuff is certificates, and it's all within our submissions manager. So you have to go there to get it, because we can't make it publicly available because they were given to CSAP, and we're sharing amongst CSAP. This is publicly available in IMAP. So he has over 900 representative borehole logs done within the province, most of them within the city of Vancouver. So you can go right in there, click on it, get the data, get the detailed data on the geology. The concerns raised before, it's not a geotechnical investigation. It's an environmental investigation. So you can't look at it and say, how am I going to put a foundation on a building? And so that's one of the concerns you're going to have to see. but you can certainly tell what you're going to encounter when you go out to the field, especially with the density of information that we have in some areas. It's amazing the amount of investigation work that has been done. So here's 215 with hydraulic conductivity values. And here's what you'd see when you bring up the details on it as to what the hydraulic conductivity is. Depth to top of screen, depth to bottom of screen, what unit number it is, how deep do you have to go down to find water. So there's a lot of very, very valuable information right there that was put together. And this got me into thinking and saying, here's a co-op student, and look at what he put together. I mean, it's a huge amount of information. How much more information are in those files? And what could we do with that information? So lucky for me, I've got somebody who works for me who needs to do a master's thesis. And I went and saw Steve Dankovy and said, how about if we looked at Kamloops, and we looked at all the metals data in Kamloops, and we tabulated all the groundwater data, and from that, she could get her master's thesis. We could get a good set of groundwater data in Kamloops for the different aquifers. I know from my personal experience that I've had a couple of sites with selenium way above standards, which was a background issue. And each time I had to do a background determination for it, or a risk assessment. So, and it doesn't make sense as me as Hemera to go out and do all this work, because I get a site, somebody pays me to do it, I make money. I don't have a site, nobody pays me to do it, I don't make any money. But if we could do it together, then we could have it all put together and it would just work for everybody's use. So what we're still in negotiations to get it all put together, and Kelly said, don't jinx me by presenting this, but this is what I want to think about for the next year's research projects, as where else do we have an issue within the province where we probably have all of this data sitting within the Ministry of Environment or within our own files that we can compile together, and then it'd be useful for everybody in the future. I know there's a selenium issue in Kamloops because of a couple jobs that I've worked there, and I've seen it 2 or 3 times. There's apparently a uranium issue, but where else can we do it? And that's what I would like, sorry Beth, for you to vote for, is for somebody else, not necessarily Hemera, but whoever, to be able to take on a project like that, where I'm getting free sweat and labor from a grad student. Sorry. I did it once, so anyway. But it happened to everybody here, didn't it? Well, most of us. But we can probably get some money next year to be able to do it. So we have 4 minutes for questions. I was going to go in and show you how to access it, but if lots of people have seen it, I don't need to do that on the new site. Any questions for me or anybody else? Yes, Vijay.
I'm not sure if I missed it, but is there a way to differentiate between post aquifer and the real aquifer down below?
No. Yes and no. Where drinking water has been ruled out, on some occasions, it's only been ruled out for the top aquifer. And if you went into the certificate, you'd be able to see which ones are only ruled out for the top aquifer. It is not a different color. It is not a different flag.
I've had a few sites where the real aquifer is sitting at 80 feet.
Yeah,
And then
I do
having-
too. Yeah.
Especially for dry cleaning sites where I've had the need to look into that. For dry cleaning sites,
Yeah.
I
Yeah.
had to look into the deeper groundwater table.
That's right.
I think it will be useful if we are able to differentiate that.
Yeah. Yeah, I think so too. And we can put that in for next year or the year after. Yes. You know, the data is reliable. Okay, so with the QC process, the CSAP puts it together, then it gets put in the system. I review it. So the first time around, I spent about a day going through it and checking stuff. Right now, Anna's going right to the summary of site conditions, whether drinking water applies or doesn't apply. So it's as accurate as the person who's submitting the reports. You cannot, if you're going to rule out drinking water on your site, you can't say, I'm ruling out because these 3 people did. You have to rule it out for your own reasons. Part of your reasons could be getting those reports from the Ministry of Environment and reviewing how accurate it is and then using it. It isn't a catch-all. Now, there's some where you have so much data, downtown Vancouver, Southeast Falls Creek, getting there with Mount Pleasant, that we'd like to be able to have a ruling from the ministry saying drinking water doesn't apply here. But we haven't gotten there yet. It's a process, it's time. And just like if you're reviewing a report, came from this consultant, you know it's really, really good. If it came from this one, you kind of read it twice.
Thanks very much, Peter.
Thanks, guys.
Very interesting. So to wrap up before lunch, there's an item here called general questions. Maybe we'll put those off until while you're eating, but the thing is we're right at noon now. I'm going to actually ask Beth Power to come up. Every year, CSAP through the technical committee awards scholarships to deserving individuals. Sounds like there's a devious motive here is to help Peter Reid get some good mapping work done here, but I suspect there's more to it than that. So I'm going to ask Beth to make some awards.
Between you and lunch, CSAP generously funds 3 scholarships, $5,000 each. And the idea is that the students who apply are engaged in a natural or applied science program leading to a thesis. The decision criteria, they're supposed to be starting or, not at the finish of their project. And ideally, it's related to the remediation or investigation of contaminated sites. So we had 5 applicants this year. I'm very pleased to tell you we did choose 3 people. They were all the applications this year were of high quality. We could have awarded scholarships to any of them. So it was a difficult decision. The first person is Keeleen Scully, who's not here today. Master of Applied Science at UBC. The project is generation, fate, and transport of methane and benzene in the Vado zone following alternative fuel spills. So looking at future COPC issues. So biodiesel and ethanol blended gasoline. So that's a award to Keelan. And I'm going to call Melanie St. Arnaud up. She just joined us and make sure you go and talk to these students. Oh, thank you. I'm supposed to press buttons. Oh, that was last year.
Oops.
That's okay. Melanie, come on up. Melanie is doing a PhD at UBC in mining engineering, and her project is release and attenuation of metals in neutral and alkaline rock drainage from mine waste rocks. I tell you, Melanie, you had such a breadth of experience. Melanie's been working as a consultant in government, and her thesis topic is very topical in the province of British Columbia. So congratulations. So one to watch on the metal side. And then we also have the next award, a third award, to Michael Zima. He's doing a Master's of Geological Sciences at UBC in hydrogeology. So you hydrogeologists, make sure you meet him. He's going to be looking for work soon. And his thesis is geochemical characterization of the hyporheic zone. He's working on that famous site in the Fraser River that we all know and love. And he's been developing novel methods to freeze sediment cores, for example. So come on up, Michael. I don't know where you are. Congratulations. Did you get to meet lots of hydrogeologists already?
So far, so good.
Okay. Thank you, Guy.
Okay, thanks. Thank you. I think it's lunch break now.